At the start of July, we added observability for GitHub Actions, something that has been highly requested across the entire GitHub Actions community, depot related or not depot related. The observability for GitHub Actions today, when you're using GitHub hosted runners, is frankly abysmal. They collapse all of the logs. You have to click through multiple tabs to see what broke. You can't easily search the logs. You don't have any metrics about what happened on the runner. Like, you don't have any metrics around did the runner run out of memory or was CPU throttled or anything like that. So we spent a lot of time and energy in building the observability layer for GitHub Actions that we wanted that's actually useful. And so we launched that at the start of July. What that effectively is if we go look at one of these, let's look at an actually interesting one. We can look at this benchmark GitHub Actions job. And what we see a couple different things on here. One, the most important thing is, for whatever reason, in the year 2025, GitHub Actions collapses all of the logs so that you can't actually see the logs. You have to individually go and open each and every one of them. So the first thing that Depot users see is all of your logs are not collapsed. They are automatically opened. You can search for anything in here. So we can search for our actions, checkout. Let's just do actions. Oops, I have a typo. And so here we can find anywhere where I'm referencing the word actions. I can do pretty slick things in here, like I can expand the context of the search result. So at the moment, when we find a hit for your search result, we show you the before and after line. But we can actually change that, and we can say, I actually want to see, let's call it 10. I want to see the 10 surrounding lines around this. This is super useful. This job did an error, so we won't find an error. But if we were searching for an error and there was an error here, you would be able to see the full context of what happened leading up to the error and what happened after the error. So these are actually useful logs. You can quickly search them. You can get all of the details around them. But what's really cool is what you'll see is as we are scrolling the logs, we want to watch these CPU and metrics graphs up here. So the green line is memory, the purple line is CPU. This is what was happening on the CPU and memory on the runner when this job was running. And as we scroll through the logs, we can see, okay, at this point, the CPU was at 32% and the memory was at 15%. The logs are correlated directly to the CPU and memory metrics. And we can do things like click here or say, okay, the memory here was 69%. What was this doing when it was at 69%? And we highlight the line and we see, oh, it was extracting a Docker layer tarball. This is really powerful stuff, because if you can imagine if your memory was at 99% or 100%, you would want to jump to that line and see what was actually happening on the machine. We also take this a step further, and for each step in a job, so this step is called build binary, we can go view process details. And what this is going to show us is during that step, what was everything from a process level that was running on the machine. So here we see that Docker D was running, so the Docker daemon was running. We see that it was using an average of 6% CPU. It peaked at 28%. It was using under 100 megs of memory. And we see a bunch of other things. So we see things like the depot CLI, unpig-z, which is effectively a way to compact and uncompact Docker layer tarballs. And we see all of this at a process level. And so this is really cool, because if you had something here that was taking, let's go look at this. This was at 73%. So here we peaked at 73%. We were just in the build binary, but you can essentially correlate all the way down to a process level of why was the CPU pegged? Why was the memory pegged? In addition, we also show things like where did the job peak? So it peaked at 82% memory. This runner type has 8 gigabytes of memory. It peaked at 69% CPU. This runner type has 2 CPUs, so use 70% of the CPU capacity. And we don't have a demo over here, but effectively when a job runs out of memory, we also show you things like why it ran out of memory and alert to you that it did run out of memory. back to the average memory and peak memory, here's an example of a job that is using a 2 CPU runner on ARM. And notice that it's barely using any memory. What's important here is you're paying for this memory, you're paying for these CPUs. So developers can essentially come in and look at this data and make the decision of like, oh, I'd like to save a little bit of money on this GitHub Actions job. I'm going to reduce the runner size, which is something that we have available inside of Depot. And so that's where the average memory, the peak memory comes in. What we would like to add in the future is effectively a really clear like recommendation system. So you could imagine seeing your list of jobs out here and being like, oh, like these jobs are over provisioned. You can reduce their size. So that's something that's like the next evolution of the observability stuff. But this is super cool. It's super powerful. We are, because I get this question a lot, we are in the process of making this available across all of your jobs. So you can see this type of metrics and all of your logs across all of your jobs. That's something that we're probably looking to add by the end of the year.